quite often we want to know in a simple or compound situation as to in how many years will my money get doubled. So we will take up both the cases, SI as well as CI, and find out the time period of doubling of money. In case of SI, we know that amount will become twice the principal. If the money gets doubled, it means amount is twice the principal. But amount is also given by the formula principal plus interest, and that tells me that principal is equal to interest, solving this equation. And interest formula we apply, PRT by 100. P and P gets cancelled, and I get doubling time period as 100 upon R. Please remember this formula. So in case of SI, doubling time period is given by this formula 100 upon R. In general, if money becomes n times, not just twice or thrice, but we will find out what happens if money becomes n times. In that case, our approach is same. Amount will be n times principal. Look at this, we will get finally n minus 1 times P is equal to I, and that is equal to PRT by 100. And so I finally get money becoming n times, the time period is equal to n minus 1 into 100 upon R. I suggest you remember this formula as well. Now let us move our attention to compounding situation. So in case of CI, what happens? Amount again is twice the principal. Now the amount formula is P into K to the power T, as I've written here. So K to the power T equals to 2 becomes the formula for finding out the doubling time period. Although I believe that this will be calculation intensive. Now to get rid of the calculations, to a large extent, we should use the formula which is rule of 72. It's a very famous rule which is used to calculate the time period of doubling in case of compounding. So the formula for this is TD is equal to 72 upon R. But remember, this empirical formula cannot be proved mathematically, and this has a limitation. The limitation is that R should lie between 5% to 12%. As long as R lies in this range, the error rate will be less than 1%, which I believe is acceptable in a CAT or ZAT kind of exam. Now look at this problem. We want the sum of money to become 3 times. Rate of interest is 20%, and they've clarified it's a case of SI. So we'll use a formula of money becoming n times. And we straight away get tripling time is 200 divided by 20, and that is 10 years. So you see, if you remember the formula straight away, that eases the matters a lot. Okay, next problem. Now we have to use this compounding interest situation. Rate of interest is 8%. We want money to become double. So K to the power T equals to 2. K is what? 1 plus 8%. So it is 1.08 to the power T equals to 2. Now we are stuck up because this calls for difficult calculations to find out the value of T. Here comes the shortcut method, which was rule of 72. And as per that, we know the formula is 72 by R. So when R is 8%, we straight away get 9 years. But please remember, 9 years is an approximate answer, not the exact answer. If I were to find out the exact answer, I'll get 9.0064 years by use of logarithms. Now you see the approximate formula, the value which I get is very, very close to the actual value. So practically we can use the rule of 72 in such kind of situations. But if you remember, the condition was that R should lie between 5 to 12%. Here in the question, 8% was in that range. But what will happen if it is not in that range? We have to use the conventional formula of doubling time period. Look at this problem now. Now we are given 20% rate of interest, in which case we cannot use the formula of 72. Rule of 72. So what do? We go by a normal approach. We have this 1.2 to the power t equals to 2. Now at this stage, instead of using logarithms, I would suggest you better use options. So if A option is used, t is 2 years, we see by basic calculations that 1.2 square is 1.44. It is nowhere close to twice. And if we do cube of that, we get 1.728, which is also nowhere close to twice. If we do power 4, we see it is 1.44 square, which is slightly more than 1.4 square. We all know 1.4 square is 1.96. So we can imagine that 1.44 square will be more than 1.96, which can approximately come to the value of around 2 or maybe a little more than 2. If you find out the exact value of 1.44 square, it will be slightly more than 2. So our correct answer is C option. All right, look at this problem. A certain sum of money becomes 8 times in 3 years. And how much time will it become? 32 times. Our basic formula is same. Amount is P into 1 plus R percent to the power T. That gives me this equation. And we cancel P, we get this. Now cancelling cubing on both sides, we get this. That is 1 plus R percent is equal to 2. And then raising both sides to the power 5. How do we get the idea we have to raise both sides by power 5? Because we want money to become 32 times, and I'll get 32 if I do 2 to the power 5. So if on RHS I have to do power 5, same goes for left hand side also. So we get this, and which means introduce back principal P. And this equation clearly tells me that the time period will be 5 years when the money becomes 32 times. Compounding period, another important area in this. Let us take the example. Suppose we have two banks, Bank A and Bank B. Bank A offers you 10% per annum and compounding is done annually. Bank B offers same 10% per annum, but now they say the compounding is done half yearly. Apparently, both are giving you same rate of interest, 10%, but there's a difference. The difference is the first bank says the compounding is done annually. The second bank says it is done half yearly. This annually or half yearly refers to what is known as compounding period. Now in compounding period situations also, our formula for amount remains the same as we have done previously, and you can see here, where the meaning of R and T have undergone a slight change. Notice that R is no more rate percent per annum. Actually, R is rate percent per compounding period. Similarly, T is no more number of years, it is number of compounding periods in the time span given to us. So to continue with the same case, in these two banks, we want to find out the amount at the end of a year, assuming the principal is 100 rupees. So Bank A, what happens in case of Bank A? The formula gives me this value 100 into 1 plus 10% to the power 1 because time period is 1 year. And it becomes 110 rupees finally. But in case of Bank B, since we have the situation of Bank B offering compounding done half yearly, but 10% is per annum. So per annum means in 1 year. So that means Bank B in 1 year gives you 10%. So in half year, it will give you how much? It will give you obviously 5%. So R will be taken as 5%. And in 1 year period, how many are the number of half year periods? 2. And so our formula becomes this, which gives me the value of the amount as 110.25 rupees. So you see, because of compounding period being different, the amounts in the two banks are different. In fact, all else being same, the Bank B results in a greater amount than in case of Bank A. So the one who is offering smaller time period compounding ends up giving more money. So if there were a bank C which was offering suppose 10% per annum and compounding was done quarterly, the amount in that case will be even bigger than in the case of bank B, which we have already seen is bigger than in the case of bank A. Bank A situation was that 100 rupees becomes 110 rupees. So my effective rate of interest becomes 10%, which basically means my principal has grown by 10% overall. But in the case of bank B, my money has grown by 10.25%. So that is effective rate of interest in case of bank B. Now, in case of half-yearly compounding situations, we can also find effective rate of interest using the formula of successive increments, which we have discussed in the video on percentage. So in case you have not seen that video, please go through that video to understand details of this formula and then revisit this video again. Now, in this case, if I apply this formula for bank B, my A is 5% and B is also 5% because A and B are per compounding period interest rates. Since it was offering you half yearly interest rate and annual rate was 10%, so half year rate will be 5%. And we get the value of 10.25. Let's take an example. So in this question, time period is 1.5 years and compounding is done half yearly. Immediately, I can say that R will be taken as 5% and time period will be taken as 3 because there are 3 half-year periods in 1.5 years. So we get this value and upon calculations, my amount comes out to 1157.625. One more problem. So read the question first. Here we are given the principal as well as amount. Compounding is done half yearly. We want to find out time period. Remember that in the formula, the T was not number of years, T was number of compounding periods. So if we apply that formula, the value of T will be, which we'll be getting, will be nothing but the number of compounding periods. So this is the value I'll get. And that gives me the value of T as 2. Do not mistake that the answer is 2 years. No. T is 2 means 2 is the number of compounding periods. So that means there are 2 half-year periods. So the time period will be 1 year. Okay. Let us apply all the concepts of compounding we have learned so far to the cases of installments. Sometimes we have seen that CAT or ZAT exams have asked questions on installments. Let's apply it. To understand this, we first need to understand the idea of future value of money and present value of money. See, 100 rupees 5 years back and 100 rupees today have different values. So 5 years back, the value of 100 rupees will not be same as the value of it today, the value of 100 rupees. How do we calculate? Suppose 5 years ago, the value of 100 rupees is given. What will be its equivalent value today? The value of that will be more than 100 rupees. And the formula to calculate the value will be same as written here. Future value is equal to present value into 1 plus R by 100 to the power n. So you see the formula here is exactly same as in the case of amount in case of compounding. This will be much more clear from the example given below. Read this question. Mukul owes so much money to Ajay 2 years hence. So first of all, let's see what's the meaning of 2 years hence. 2 years hence means 2 years in future. So this money given is future value. And if you have understood the question, he is asking to find the value of present value. So let's apply the formula. We get present value is equal to this. Putting the values, I'll get 20,000 rupees. So if Mukul plans to pay to Ajay today, the money he has to pay today will be less than 25,088 rupees, and that is this value, which is 20,000 rupees. Now, in this question, we will see how to calculate the installment for each year or for each time period. Read the question carefully. Atul has taken effectively a loan of 30,000 rupees today, which he plans to pay in 3 equal installments. So first installment he'll pay at the end of first year from today, second installment at the end of 2 years from today, and so on. So how much does he need to pay each year? Do not think the EMI or installment will be 30,000 divided by 3, that is 10,000 rupees. Because if that is the case, what happens to rate of interest being charged? You have to also keep in mind, you have to also incorporate the idea of rate of interest being charged. So let us see how do we go about it. We will use the concept of present value and future value. So this is the time zone I have written. Today means year 0. 1 year hence means this, year 1, then year 2, and year 3. These are the payouts. 30,000 rupees is what Atul receives from the loan making company. And he pays X rupees in year 1, means at the end of first year, and likewise. We again cannot say 30,000 is equal to 3x. So what do? We convert the value of each payment, whether we receive or we are giving, value of each payment at the end of 3 years from now. So what is the value of 30,000 rupees which we have taken loan today 3 years later? The value of this will be found as this, principal into k to the power 3. So it is 30,000 into 1.08 cube, because R is 8%. Similarly, the amount of money which I am paying by way of installment, that is X rupees at the end of first year, what will be the value of that X rupees at the end of third year? That means from first year to third year, that's a gap of 2 years. So it will become X into 1.08 square. There's a gap of 2 years from year 1 to year 3. So the power is 2. Similarly, the payment I make in year 2, that is X rupees, its value in year 3 will be with a time period of 1 year. So it will become X into 1.08 to the power 1. So effectively, I have paid these 3 sums of money as per the valuation in year 3. Okay. So this is the money I have paid, and what I have received is 30,000 rupees today, but 3 years later, this value, which is written there. So considering the values in the year 3, I get the equation like this. So the 3 payments which I have made is this, X into 1.08 square plus X into 1.08 plus X. This third value X is nothing but the payment which I have made X rupees in year 3. The value of that X rupees on that date itself will be obviously X rupees itself. From this equation, if I solve the value, I get 11,641. This is precisely how we calculate the value of each installment. Here I have used the formula of compounding to find out the EMI. What if the question was given as that the simple interest is being charged, rate of interest being same, 8%, and loan is same, everything else is same? In that case, you will use the formula for future value in case of SI instead of compounding. So I leave that part of the question to all of you. Please do it yourself. Let us now turn our attention to application-based questions. So our first problem is a ZAT 2015 problem. So if you read this carefully, it says, it talks of 3 years, 2004, year 2007, and 2010. So from 4 to 7, it's a gap of 3 years, and from 4 to 10, it's a gap of 6 years. we have to find out the principal value. It is talking of accumulated interest being given to us. So again, we'll assume that the principal is X rupees. CI earned, we apply the formula of compound interest. Now we are aware of the formula, so I will not elaborate it further. It becomes X into K cube minus 1. Let's say it's an equation number 1. CI in 6 years, because from 2004 to 2010, it's a gap of 6 years, and that accumulated interest is 25,000 rupees. So we get this. It is second equation. Now, from first and second equation, if you divide them, I'll get rid of X, and we get this. Now, K6 minus 1 can be factorized as shown below. It becomes K cube minus 1 into K cube plus 1, and the values get cancelled. We get K cube plus 1 equals to 2.5, which gives me this. Putting it back in the first equation, we will be able to get the value of X, and which finally is 20,000 rupees. I hope you have got the calculations. So C option. One more problem. This is of IFT. So we have to break 25,000 into two parts. Maybe X and Y, or maybe X and 25,000 minus X. So if the money in X is X rupees, so money deposited in Y FD will be 25,000 minus X. What is the CI earned in X? Now in X, the interest rate is 6%. So CI will be this formula, this value. And CI earned in Y FD will be this much. Total interest accrued is 3518. So if you add these two expressions, we will get this summation is equal to 3518, and the rest is calculations. We will get this equation upon simplification. Finally, I'll get the value of X as 15,000 rupees. So you see, it's a very simple problem which was asked in IFT paper. You just had to find out compound interest earned in these two FDs, add them up, and equate that to the total interest earned, which is given here. Let's deal with one more problem. So we have now two persons, Amal and Bimal here. Say interest earned by Amal, how much is that? He invests in two different options. First is 8% of 12,000 rupees. This is the interest he earns from the first one. And from the second one, since it is compounded semi-annually, the R will be 3% instead of 6%. So this will be the case. 10,000 into 1.03 square minus 1. If we simplify the value, we'll get 1569. Similarly, interest earned by Bimal. Now, in case of Bimal, I don't know what is the principal. So let's assume the principal is X. Our interest will be this. Equating these two, because question says they both get the same amount of interest. We get X as 20,920. Again, I feel it's a very simple problem asked by CAT. Thank you for watching this video. In case you have any queries regarding this video, you can always approach me on the mentioned email ID. Alternatively, you can also send the comments in the comment box.